Okay, today we're going to talk about Roche analysis and the quest for invariant measures, improving measurement with item response theory. And I hope by the end of this talk you'll have some ideas about measurement and item response theory and how they all fit in with the health sciences. First, I'd like to present an analogous kind of scientific inquiry, and that is our journey to Mars. The United States has spent a lot of money on lunar landers and orbiters, and these are some of the instruments that we use to get to Mars, to probe the planet, the red planet, to find out if there might have been life on the planet, what the mineral composition of Mars is, and whether there's any relationship between the history of Mars and the history of Earth. So, first question is, what are we looking for on Mars? And so that determines what kind of instruments we would send there. If we're looking for carbon-based life, we might be looking for traces of organic compounds that are unique to life. We have the Curiosity here, which is going around investigating the composition of rocks for possible life forms. And we'll just scroll through this three-dimensional picture here of Mars. But the point is, how do we assess scientifically human skills, abilities, attitudes? Skills and abilities and attitudes are expressed by somehow measuring what is inside a person. And we use surveys and questionnaires to do this, or we interview people. But what if we find that there's nothing but Martian rocks inside someone's head? Then what do? This is just a joke. In any case, whatever we glean from the analysis of data that we gather from people, we have all kinds of tools for analyzing those data. We have ANOVA, ANCOVA, MANOVA, MANCOVA, t-tests, all kinds of statistical analyses, all based pretty much on normal curve, standard errors of the mean. And here's a word salad of all the different kinds of words we might run into in statistical analyses. However, we balance the analysis of data with the measurement. We've all heard garbage in, garbage out. And if our data are based on measurements that aren't based on reality, then we can analyze with very sophisticated tools and still end up with uninterpretable findings. So how do we measure humans? What do we measure, and why do we measure it? Well, we look at designing instruments to find out something. If we're looking at IQ, we have IQ tests. If we have motivation we're interested in, we have motivation tests. If we're looking to measure some aspects of personality. And these instruments, we call them, have to be reliable and valid. But what exactly are we looking for? We're looking for something called a latent construct, something that we can't see, touch, or feel, but that we feel is there within a person and can be measured. IQ has been the traditional, rather intelligence has been the traditional latent construct that we've been looking for and try to measure. In this particular case, I'm going to use a peacock as an example. And this peacock looks blurred because it's shot in 3D. And if you have 3D glasses, you can see it in 3D. But we're looking for the essence of a peacock, or what a peacock would be by its attributes. So if we're looking for this latent construct of peacock, as an example, there are several steps we can take. So the two measurement traditions, both started in the early 20th century, are test scores and scaling. So with respect to Peacock-ness, we will talk about those things. First of all, we'll talk about test score or classical test theory, as it's usually known. And in that, we have a number of items that we write that ask questions to find out about someone. In the end, the items that correlate with the total scores are those items that we want to keep because they're considered most informative. Out of this factor structure is if the items seem to coalesce together about measuring something about a person's skills, abilities, or attitudes. And for example, I could give you the Peacock Test, which I just made up, where each true is 1 point in favor of being a peacock. Number 1, they have feathers, they fly, they sleep in trees, have bright colors, tail patterns look like eyes, they live in Sri Lanka, are large, they weigh over 20 pounds to be more specific. They are birds, they have eyes, they have beaks, they make annoying sounds, and they attack humans sometimes. Leopards like to eat them. They're tall. They stand over 1 meter tall in the adult. If you were to answer all 14 questions about the bird that you're looking at as true, then we would say that we have a peacock in front of us. But the question is, if you have less than 14 that are true, is it still a peacock? And given that this is a pretty poorly constructed questionnaire, just go along with it for the example. Some of these questions apply to more than one animal. So it's not very specific, not very sensitive to describing a peacock. This is an example from my research about test analysis, and we used a factor analysis for determining intimate partner abuse in child custody cases. You can see here that we have a factor, a general factor, for which most of the items are related by the correlation coefficients under the column entitled General Factor. There are 4 other subfactors after the variance for that general factor is taken out. And you can see some groupings, some items that are kind of correlated with the same factor and that are attempting to measure the same latent construct. And there's the end of that table. So we have an alternative to factor analysis and to classical test theory, and that's called IRT, or item response theory. Here's an example of item response theory, specifically the type of item response theory that's called a Roche analysis. Again, this is some of my work. And you can see here on the right side of this vertical axis, you'll see the items that test for knowledge by having the most difficult items at the top and the easiest items at the bottom. Another way to say that is the items at the bottom are most likely to be endorsed by more people, whereas the items at the top are less likely to be endorsed unless a person has a lot of knowledge. On the left-hand side of that vertical axis are those hash marks, and those represent the number of people that have answered those items correctly. So what this is attempting to do is make clear that the items will measure the same amount of skill across different people who have the same ability. And we'll talk more about this on Wednesday. And here is another way to describe different items. You can see the latent measure, or latent construct at the bottom axis, the x-axis. and the probability of endorsement on the y-axis, and the item number 1, green, number 2, burgundy, and number 3, blue. Blue is the item that, when endorsed, will represent a lower end of the latent measure, and green a higher end. Another way to say that is that the blue item is more likely to be endorsed, has a higher probability of endorsement, whereas the green represents a higher level of the latent measure, knowledge, ability, skill, and will be only endorsed by those people who have more ability. So with that, we'll see you on Wednesday for the full presentation.